Hello, and thank you for joining our Signal Media webinar, Securing the Kubernetes Software Supply Chain from Increasing Cyber Threats. I'm Diego Laje, Senior Reporter with Signal Magazine, and I'd like to welcome you to this online event. The opinions expressed in this webinar are of the presenters and are not to be construed as official or reflecting the views of FCA International. During this webinar, sponsored by Rancher Government Solutions, we'll talk about security and compliance with the Kubernetes ecosystem. The software supply chain has become the top security concern across the federal government and the military. Following the SolarWinds and Log4j attacks, securing the software supply chain has become extremely important due to the criticality of software to government operations. Rancher is the leading open source software stack for teams adopting containers. Chainguard gives federal users confidence in the critical open source software they deploy by providing a way of signing and verifying software artifacts so they have a verification trail. RGS's solution utilizes Chainguard's secure images and other security tools to ensure that Rancher products their clients use are secure and can be verified with SBOMs. Joining us to discuss the threats to our nation's Kubernetes software supply chain and how to address it is Rancher Government Solutions Vice President and Chief Technology Officer Brandon Gulla and Chief Architect Adam Toy. Joining them is Dan Lorenc, the co-founder and CEO of Chainguard. Before we get started, I strongly encourage you to ask your questions using the query box on your screen as early as possible, as there will be a Q&A segment at the end. If you'd like a specific speaker to address it, make sure to include that. Now, over to Brandon.
Great. Thanks, Diego, and thanks for having us today.
Great having you.
So, everyone, thanks for coming. My name is Brandon Gulla, as Diego said. I represent Rancher Government Solutions. So we are the exclusive provider of all things Rancher and SUSE technologies for the U.S. military and federal community. We are different from most vendors that integrate within the federal community because we are exclusively tailored to the needs and wants of the U.S. federal community. We see so often that commercial entities, try to dip their toes in the water of all things federal. And that's not enough. You need a dedicated resource and a dedicated team that understands the challenges and unique opportunities that the U.S. federal market provides, especially when it comes to things like high compliance, Airgap, as well as DDIL environments. You often need that trusted advisor and the actual workforce that's been in those environments, stood up networks in that environment to be able to hit the ground running for you and your mission. So we actually offer support and technology for all things cloud native. That's both in the cloud and on your own on-prem environment, extending now into the tactical edge. Us as an application stack, really exist in that containerized ecosystem from the Kubernetes layer up, as well as SUSE from an operating system as well with SLES. So what we specialize in is everything that the government cares about, things like PKI authentication, SE Linux, STIGs, all things hardening. We'll be talking about that a lot today, but know that we're the trusted advisor for all things cloud native in the Kubernetes and government community. So what do we grade ourselves on as an organization? When we got started with this organization 3.5 years ago, I wanted to set out to be a mission enabler and one that the mission partners can trust. And in order to gauge that success against ourselves, we have 3 unique pillars of excellence or success that we like to pride ourselves on. So number 1 is enterprise support. Our Follow the Sun organization here within the United States has only CONUS-based engineers, many of whom have clearances and worked in these environments, providing you that world-class service, both via ad hoc comms like a phone or a Slack channel, or even on-site support and TAM operations. We want to be there to ensure that we're that throat to choke and the phone to call whenever something goes wrong or as you're advancing your cloud native strategy. We also have a budding professional services team. We're not trying to go up against the Lockheeds and the Booz Allens of the world and the other GSIs, but we want to provide tactical teams that can come into your organization and be an incubator and a cloud native evangelist and advocate for your organization to get to cloud native faster. So most notably, we have prime contracts on Platform One, as well as many others, where we are actually leading not just our tooling, but the overall cloud native architecture in general. And of course, the third pillar that I take a lot of pride in, and so do most of our all of our engineers, and that's the mission accelerator standpoint. We want to be able to find the small things and the large things that we can do within our product to make the lives of the mission and SCIF dwelling engineers that much easier. I've been there. I worked in a SCIF for 10 years of my life. I understand the challenges, especially when it goes to low to high and the dependencies that you often see. We want to make the lives of those SCIF dwelling engineers and mission technologists that much easier. So if it's something as small as just adding classification banners, or something as large as creating a secure by default distribution of Kubernetes for the US federal community, we want to take that on ourselves to promote it and propagate it throughout the federal community so it deduplicates that effort. So we do that with our cloud native stack. There's a lot of boxes here, but what I really want to showcase to you is that we plug in anywhere. It doesn't matter if you're running Ubuntu, SLES, Red Hat, CentOS, Rocky. We will exist and actually support with ELAs and enterprise terms those environments. If you're on AWS, C2S, SC2S, Oracle, Azure, we're there to be that cloud agnostic and infrastructure agnostic provider of cloud native solutions. We integrate with all of your stacks that you probably are using today, from Active Directory, or if you're using Istio for service mesh, we plug in a non-prescriptive and non-forceful way. So I mentioned that we can deploy Kubernetes anywhere. We're seeing now with the JWCC contract, among many others, that the US government is now opening the door to choice. We want to be that fabric that lays on top of the different cloud providers. And of course, as you decouple your application from your infrastructure, you always bring on the sixth cloud that everyone likes to forget about, and that's on-prem. So Rancher can actually provision cloud native applications and clusters to all of those instances of, types of infrastructure from one instance of Rancher. So we want to be that multi-cloud, multi-cluster management backplane for your entire Kubernetes organization. So as I mentioned, we're open. We play with all the Linux distros, all the hybrid cloud architectures. No reason to beat that up. Why can you trust what I'm saying and trust us as a company? We have active ATOs with all the nice logos you see in the slide, as well as many others. We are the trusted advisor to many of these organizations and are proud to serve their missions. So how do we do that? We do it through our innovative list of products. So I'm not going to go through all of these. Many, hopefully you've seen before. Rancher is our multi-cluster management backplane. Did not mean to transition that. Rancher is our multi-cluster management backplane that manages your entire Kubernetes enterprise and hooks in things like IDAM authentication, logging, compliance as code, secure by default practices. That's all baked into Rancher. And that deploys Kubernetes clusters in the RK2, or secure by default distribution, or K3S, our edge focused distribution of Kubernetes. We also have a slew of supporting projects that fit into the Kubernetes ecosystem. Regardless if you're using our Kubernetes distribution or someone else's, we want to be able to advance your mission no matter what. And that's using our block level storage provisioner with Longhorn, Harvester as our hyperconverged infrastructure stack, NewVector is our complete security platform for all things container security, as well as many others. Many of you have probably tried out Rancher Desktop as well. That's one of our projects. We have our product list that we support officially, as well as putting out projects for the open source community on a support by best case basis. Those are our projects, and that list will continue to evolve. So Kubernetes itself does not ship in a hardened state with all best practices turned on. I want you to think of Kubernetes as a big switchboard or a control board in an aircraft or in a space shuttle. There's a lot of knobs. And in order to get to a secure state, you often have to turn a lot of those knobs by yourself. Well, with CISA recently coming out with their guidance saying we need secure by default and secure by design to be practiced by the vendors, that's a model that we actually took a little over 3 years ago with our implementation and distribution of RKE2. So RKE2, formerly known as RKE Government, is our secure by default government-focused distribution of Kubernetes that takes all of those security knobs and cranks them up to 11 by default. Things like etcd encryption, the key value store within Kubernetes itself. We turn the encryption on by default. Things like SE Linux, we actually wrote the patches into the containerd runtime and pushed those back upstream so everyone could take advantage of them. And most importantly to this community, we also bake in FIPS 140-2 and soon FIPS 140-3 from an encryption at rest standpoint. So we have a NIST validated encryption module that we've actually gone in and rebuilt RKE2, the Nginx load balancer, the actual containerd runtime itself, and other supporting tools. And they are actually validated against that NIST FIPS 140-2 encryption standard. We put that into the open source product. We didn't want to hide that behind the gate because we believe that security is good for everyone. So that's why we released RKE2. And we built RKE2 in partnership with Platform One at the time, who was a great partner in giving us the requirements and helping us build this product. So I mentioned how CISA has evolved to this secure by default and secure by design model. Jen Easterly, the director of CISA, was quoted here, as you can see, as well as CISA just released a paper that I'll reference later in the talk, where it says that the responsibility of security should not be solely on the end consumer or mission partner. It should be on the vendor itself. And we should be adopting methodologies that actually bake security in by default. And it's better to have a hardened product by default. And then rather than creating a hardened product, actually a hardening guide, release a loosening guide. So you have that opportunity to at least achieve that hardened state by default. We're seeing that not just in the products, but in the dependencies of products and how our mission partners are building their application stacks. And in a containerized world, that often means inheritance and starting with this secure base. So with that, I actually want to bring on Dan Lorenc from Chainguard to talk about what Chainguard is doing, both for the commercial and federal community and the open source community at large. Dan?
Yeah, thanks so much for having me on today, Brandon. I love everything you said before about this, about secure by design, secure by default. And yeah, I love Jen Easterly's talk and push inside of the federal government about all of that too. I'm here to talk a little bit about what we're doing toward that front at Chainguard as part of the secure by design and secure by default initiative for cloud native technologies, containers, and more. Next slide, please. Awesome. Yeah. So Chainguard is a software supply chain security startup. We are about a year and a half old. We got started toward the end of 2021. Before starting this company, I was a software engineer at Google for about 8 or 9 years. I worked with a lot of my co-founders on secure infrastructure, open source technology, and that intersection of secure open source consumption and distribution. The field heated up in 2021 as a result, and in the wake of the attack on SolarWinds, as the entire industry started to pay attention to software supply chain security. That term has actually only been in the common lexicon in the industry for the past couple of years. It's been around for a long time, and this overall problem is something that we've known about, honestly, dating back to the 80s. Our startup is about 60 people now, a little bit more than that. And we have raised a whole bunch of funds from some of the best investors in Silicon Valley to help on our mission here. Next slide. Yeah, thanks. Jumped around a bit. There we are. Awesome. Yeah, so this slide kind of puts into perspective what we think of when we talk about software supply chain. I almost hate the category software supply chain in the term because it's so broad and it's so hard to actually explain what you're talking about within that category, because it's a whole bunch of different threats that happen at entirely different spots in the application lifecycle. So there's no one size fits all solution. There's no magic bullet. There's no magic answer here that a single vendor is going to be able to provide to secure your entire software supply chain. This little graph here depicts actually just one small portion of this, because this is a software supply chain just inside of one company or in one organization. You have to remember that the supply chain is a connection of all of these little graphs across companies, across organizations, across governments, across countries, across the entire world. But yeah, this is really a development time problem. Software developers are the ones that operate and orchestrate and choreograph the flows of software artifacts, build tools, commits, source code itself as it makes its way through this pipeline. And this is just a short depiction of some of the threats that can happen in here, especially when you have to factor in open source code and code being written by folks outside of your organization that you might not even necessarily trust. But every single one of these links is an attack vector. In the past couple of years, we've seen attacks on every single one of these. So at Chainguard, we're starting to approach this from the bottom up and building secure by default tooling that can help address this at every single point in the pipeline. Next slide. Yeah, so we actually call this fortified software delivery. The delivery process of software encompasses everything from a developer typing code on a keyboard on their laptop to getting it out into production. These are three of the different areas that we're focused on. Build it right. Right. If we're going to fix this and address this and make this a secure by default change across the industry, then we've got to start at the bottom and build things right. So what we're working on here is we have an open source Linux distribution named Wolfie, WOLFI, that is set up to factor in all of these software supply chain goodies from the start. That includes things like signatures, SBOMs, vulnerability management, key distribution, all of the aspects that would go into designing a Linux distribution from the ground up to be as secure as possible for a cloud native environment is what we're doing here. It's a dream project for a lot of engineers to work on because we're starting from scratch, starting at the bottom and working our way up. We make it easy in this Linux distribution for compliance. This is one of those areas where I think the compliance groups and the folks building these standards at NIST and at CISA have done an amazing job aligning these standards, aligning the things in the secure software development framework with actual industry best practices. And we're going to see a lot of improvements as an industry as folks actually start adopting these compliance frameworks. So with our images that we build using our Linux distribution, it's much easier to get FedRAMP certification because the vulnerability management is taking care of you. We actually provide a 0 CVE SLA on the images, so it makes it much easier to get to that point without having to fill out tons of POEMs. And we package tons of cloud native applications in here, so way beyond what you would think of in a typical Linux distribution. You can run our package manager to grab most of the projects on that kind of massive, overwhelming CNCF landscape, stuff that hasn't made it into most other traditional Linux distributions, not designed for a cloud native environment. Because we do all of this from the ground up, we get SBOMs generated automatically through the build tooling. So you get great, accurate SBOMs that don't leave things out and include the data you need to be able to verify what is inside some of these packages and running containers. And of course, all of this is signed with the open source SigStore tooling, which Brandon talked about, and we're going to keep talking about later today. So you can verify the integrity, you can verify the container you got, you can verify attestations, who published those SBOMs, all of that data, and you can look that up in a cryptographically verifiable ledger. The cool part here, and where I think we need to get to as an industry, is if we do things like this and we have a fortified software delivery process and it is actually secure by design, we need to get developers to adopt it, right? That's always the hard part here. And as we know, developers, I am one myself, developers are very lazy people and we will always do the easiest thing possible. So that's a point of friction here with most security tools as you try to adopt those in the development environment. The interesting part, though, is there's no reason that doing development securely has to be harder. Right? A lot of these problems and things that we face in software supply chain security are really just about knowing what code is running where and how it got there. There's no reason that has to be hard for developers. And in fact, it can actually improve the development experience, having fine-grained information about exactly which commit is running in which production data center. I think anybody here would be lying if they claim they never wasted a day debugging code only to find out they had the wrong version running, and that's why the print statements weren't hitting. Right? If we do all this right and we build this into tooling, developers shouldn't have to think about it, and it should actually improve the development lifecycle rather than get in the way and act as a hurdle. Next slide. Yeah, so this gets into a little bit more of our Chainguard images that I touched on before. So from our secure by default Linux distribution, we produce a whole set of secure by default images. These include things like base images that you can build your application and your first party stuff on top of. So that's language runtimes like Java, Node.js, Ruby, Go, Python, .NET, any of those kind of runtimes that you might want to put your application on top of. We're very flexible here, so we support multiple versions of all of these languages, and we've built a ton of automation to be able to backport and forward port security fixes across all of these. So your developers get choice; they get to pick the actual version of the runtime, or compiler, or virtual machine that they need. And we work to make that easier for them, so they're not stuck with a limited set of libraries available or using an older or outdated version of a programming language runtime. And again, because we do all of this through the build process, and we've built a ton of automation around this, we can get you SBOMs, we can get you signatures, we can get you all of those compliance artifacts you need as you ingest these open source components into your organization. Brandon used that metaphor earlier, a throat to choke. We are a throat to choke here for all of these kind of open source and container images that you're pulling in to run alongside or underneath your application. This is huge for FedRAMP, for FIPS, for PCI, for other compliance frameworks that require you to have a vulnerability patching plan for anything that you're running. Next slide. Yeah, here's a little bit of a deep dive and some architecture around how we actually build all of these and what the end results look like. But we have our own custom tooling to build all of these images directly from source. So we're building everything inside of these images from source ourselves. There's nothing inside of them that we're consuming as binary artifacts or anything. There are a couple different benefits to that. One of them is that we can patch everything going on in there. We can directly patch any of the vulnerabilities that get reported. Because we can patch those, we can keep vulnerabilities low, and that's how we do it. All of these builds are done reproducibly. We have a custom tool set that locks down the environment and makes sure that the same bits coming in are the same bits on their way out. We generate provenance as part of this build, so you can see exactly how these things got produced, what machines they were on, and that's all done with verifiable, cryptographically verifiable signatures, and we keep them up to date constantly with continuous builds. So you can see some of the screenshots here, just kind of showing the size difference between Chainguard images and some of the more popular ones floating around that don't come with these guarantees. They're much smaller, they're much easier to manage, cheaper for your ingress and egress as you're uploading and downloading these containers, and then 0 CVE scans for most of the common scanners. Next slide. Awesome. So because of this, we are able to produce and provide optimized tooling by building all this from the ground up with this hardened tool set. We automate all of those supply chain security best practices, and we kind of live that ethos that I mentioned before. We build everything from source to production, and we can do this in a productive way. It's not actually harder for us to do this. We can get a request for a new package or a new language or a new image, and we can get it up and maintained and automatically patched and hardened in minutes or hours, not days or weeks or months. So by building a hardened tool chain, we can actually be more productive and ship more code and maintain it easier with fewer employees and lower cost. This is all built on open source. Again, like I mentioned before, the tool set is listed here. Melange is our tool for building packages in a reproducible, secure way. These packages then get used in our open source Linux distribution, or we jokingly call it an undistro, because this is just for containers. We build everything except for the Linux kernel itself. The Linux kernel is typically provided by your host operating system. So it's somewhat of a Linux undistro in that sense. The tool that we then use to manage the built images is called APKO, APKO. That turns these packages directly into images, again, reproducibly. If you ever see build date 1970 at the bottom, that's how we're able to keep all of the timestamps out and keep these images built reproducibly. We have a whole set of free images that you're welcome to use, as well as a paid enterprise offering. The free images are there in the public Chainguard image catalog, and those typically include the latest version of different programming languages or applications that you want to be running. That's a big win if you can live on the edge and have rapid updates that way. But our Chainguard enterprise offering is for older versions or specific versions of the packages that you might need more control on of when you want to roll them out. We have a huge amount of adoption of the free tier, the public image catalog among open source projects. So you might already be running our Linux undistro, whether you know it or not, in some of your environments, just because of the benefits we provide to open source projects as well. Final slide. Awesome. And as part of this free tier, we've actually worked directly with the Platform One team to make our images available inside of the Iron Bank. So I think we have Python, Node.js, and Go, maybe a few other of our free images are actually available inside of the Iron Bank today. So you can get started using those. We've worked with a few folks trying to get other images in there that build on top of these as base images, and it typically makes those VAT scores and vulnerability scanning reports much easier to manage as you're trying to get things into the Iron Bank for use inside of the DoD or the federal sector. So give those a try, and if you're interested in more images in the Iron Bank, we can pretty easily get more of the free images added. So thanks again, Brandon. Back over to you.
Great, thanks, Dan. So I really appreciate you coming on and sharing everything you guys are doing with Chainguard. It's funny, you just said you may be running Chainguard images whether you know it or not. And I think that should be a big theme to our talk today, because so commonly, infrastructures, or excuse me, organizations will deploy software and just do a Docker run or kubectl apply and have no understanding of what is actually composing their software and what dependencies that software has. And I think, it's scary to think you don't know what's running on your system until you actually use tooling such as, Cosign and other tools to ensure that you have that ledger and that transparency of what's actually running in your setup. So I know you probably didn't intend for that, but that definitely piqued my interest when you said it, because I think it's a big theme of this talk.
Yeah, the fact that you can be running something like that without knowing it is a testament to the poor state of software supply chain security across the industry today, and proof that we have a lot of work to do as an industry.
Yes, we do, both federally and commercially. I know this is a problem that's shared throughout the entire technology sector, so I appreciate it. So I would like to introduce something that we released back in March called Rancher Government CARBIDE. And what CARBIDE is, it's our federally focused distribution of the entire Rancher portfolio, tactically built for the federal community. What that means is we're actually taking every product and image that Rancher Labs and SUSE produces, bringing it in-house and running it through our unique build process that's using a lot of the foundational tools that Dan mentioned a few minutes ago. Things like Cosign, as well as Gripe and Sift and other tooling, which I'll discuss here in a minute. But what we aim to do with this distribution of our Rancher portfolio is provide a more secure alternative built to spec to the unique needs and challenges of the U.S. government. So this is different from our free and open source product in Rancher. This is a customer exclusive distribution, but our customers have asked for more. We need more than just free and open source. We need more knobs turned. Much like the success that we saw with RKE2, we want to extend that same secure by default and secure by design methodology into the broader Rancher ecosystem. That's why we built CARBIDE. And in order to do that, we had to find our goals. What are the 3 unique goals that we want to achieve by releasing a new distribution of the Rancher portfolio? Number 1 is accelerate the path to production. And while that may not sound like security, in reality, it is. The U.S. government, starting with the RMF Plus process back in the late 2010s, opened the door to inheritable security. And what they mean by that is by achieving certain controls underneath your application structure and having those controls assessed and signed off, rather than reassessing the entire stack from 0 to 10 every time you want to release an application into production, you actually have the ability to inherit from the controls and the security assessments that have already been done ahead of you. So for example, whenever you deploy an application or get an ATO on top of AWS C2S, that's actually inheriting from hundreds and hundreds of controls where people have gone in and actually verified, okay, the physical security, the digital security, the encryption standards. You don't have to subject your entire application to the gamut of security assessments every time. So what we wanted to do, and now coming back to the point here, what we wanted to do is actually provide a mechanism in which we can provide more transparency to create more inheritable security assessments. Put that information at the hand of the cyber teams and the assessors, so they have the opportunity to create an easy pass lane towards a mission environment or production environment, giving our application teams a lower cost to mission, as well as accelerate that path while remaining secure. Number 2 is validate the software supply chain assets, even in Airgap environments. So, most commonly, anyone who's ever worked in a SCIF or in a high side environment knows the challenges that commercial software often provides in Airgap settings. Dependencies of dependencies, as Dan mentioned earlier. That's not just a problem when it comes to supply chain security, but also operations and getting software into the high side. We want to ensure that all of our Airgap customers and users are first-class citizens. So everything we've done with Rancher CARBIDE fully extends into the Airgap environment, including validating our excuse me, our digital signature against our images, which I'll be talking about in a minute, as well as the attestation and SBOM support. So number 3 is automate compliance as code. You'll hear about this in a minute, but we've built a tool that will automate a lot of your compliance needs by default. This tool will actually go in and check the host level security enablements of your downstream RKE2 and Kubernetes clusters to ensure that you are not drifting out of that approved security baseline. So it's not just important for us to be able to hand you the tools needed to get to an ATO. We want you to remain secure from day 2 to day 365 as well. And that's just a little what we hope to achieve with CARBIDE on IOC, and we've done a lot more than that. So what is CARBIDE comprised of? So number 1 on the supply chain security side is software bill of materials. So as Dan mentioned earlier, you need that ledger of dependencies. How do you know whether or not you're running log4j version 1.83 or whatever version is vulnerable? In order to do that, you have to enable that transparency. All of our Rancher images that we produce with CARBIDE actually come with a software bill of material injected in that image as an image layer, allowing you to use Cosign or other tools to actually pull that out and be able to verify that SBOM and view it in a dynamic manner. So that's not just, the versioning. That also includes things like licenses when it comes to GPL licenses, as well as what kernel it was built against. We're enriching the security metadata of every image that we provide our customers to give you that rapid and relentless transparency to ensure that you're making the risk mitigations that your organization needs. To follow that relentless transparency, of course, is vulnerability scans. So we actually go in and run Trivy and soon new vector scans against our entire fleet of images. This provides you with the understanding of what is the risk of an image before you even pull it down onto your system. Commonly, you might want to check to ensure that, maybe you're pulling down an old version of Rancher that, is a year old. That's probably chock full of vulnerabilities and CVEs. In order for you to have that risk assessment, rather than pull it down to your network, you can actually use our tooling to pull that information down and have that awareness before you even pull it down. Of course, we want to produce CVE-free software, as Dan said, starting off with Wolfie as a baseline on some of our images, and everyone should strive to have, vulnerability-free software. But in reality, it doesn't exist. And especially with time, if I produce the world's most secure baseline of software today, in a week from now, it's going to have vulnerabilities. Just like Dan said, with nightly builds, you have to replicate those builds on a constant basis to stay ahead of the attackers. Software at rest is vulnerable software. So that's why we actually include the malware scans and the vulnerability scans directly within our image, much like our software bill of materials. We want to provide that radical transparency that your organization needs before deploying these software artifacts into production. Additionally, attestation scans. So attestation, as Dan mentioned, is the opportunity to have that software provenance, to know who and what built that software and where those commits came from. This is so critically important, especially in open source projects where you're accepting commits from the outside world. You want to have the assurance that there is a verifiable trust chain with hashes to actually couple that identity to the commit, to ensure that your organization and your software is being built by teams and code commits from teams that you trust and not bad actors. So we actually provide attestation reports for every piece of software that we build. One use case of this that I like to talk about sometimes is in 2001, I believe, some university professors up in Michigan actually set out to test the supply chain security of the Linux kernel. Linux kernel is everywhere. It's in everything from our phone to our computers and now our Apple Watches and everything in between. It's the baseline of computing functionality today. So obviously you want it to be secure. And they intentionally put malware into the Linux kernel just to see if it would actually be accepted into the supply chain. And unfortunately, it was. And they didn't find out for many weeks later they being the Linux kernel maintainers, what happened. But how do you trace that malware back to a unique actor and who actually wrote it? You do so through attestations. You can also view Git and things like that. But the binary artifact itself, it should be there as well. This allows you the opportunity to have radical transparency back to every hand in operation that has touched your software code base. All of this is provided as an authenticated registry that is actually powered by Azure Government with Azure Container Registry. So the workflow, which I'll talk about here in a minute, exists where you pull down the images from our Docker registry and then host them on your own trusted registry, whether in Airgap or in a commercial setting, and actually farm those out to your clusters. But we wanted to have a trusted source rather than just a public registry, if you will. That's why we chose to partner with Azure Government to produce that. And of course, what good is having all these security enhancements in the image if the image itself is tamperable? That's why we've gone in and actually digitally signed each and every image that we produce with our public key, ensuring that cryptographic pattern matches our standard and our fingerprint. So you have the awareness that this image has not been modified. It came from us. It was not man in the middle downstream. We want to ensure that you have the transparency and the auditing capabilities needed to know that your software is coming from us and is trusted. So what does that look like? Here's our build pipeline that's actually powered by Tekton and several tools that Dan, both in a previous life and current life, and his teams have produced. And what we actually do is pull down the images from Rancher and then subject them to the gauntlet of security scans that I talked about earlier. Very soon, we're actually switching to a model where we're going to be rebuilding each binary on-prem. And this is all done on, AWS GovCloud. So we're actually using both Azure and AWS GovCloud in the Gov environments to ensure that we have that operational integrity and that uptime needed. So what we're actually doing is taking those images, subjecting them to all the rigorous scanning methodologies that I talked about earlier, digitally signing them, injecting all those image manifests, and then signing everything with cosign from SigStore. So that gives you that digital signature that you can actually take into the high side or an Airgap environment and run cosign to ensure that you're using a trusted image. You then push all those artifacts to your registry, and then you can use them in your cloud native deployments. So everything you're seeing here outside of the big gray box is the same standard that you use to deploy your images today. But everything within that private cloud, we want to show you the transparent nature in which we're building these images so you can be rest assured that they're coming from a trusted source with the proper controls in place. So let's talk about Stigatron. So Stigatron is not the new hot toy under your Christmas tree this year. It is our unique day 2 operator to ensure that your downstream Kubernetes environments are built to the DISA-STIG standard. So here at Rancher Government, we're very proud to have 2 active DISA-STIGs in both our Rancher Manager or multi-cluster management backplane, as well as RKE2, our secure by default distribution of Kubernetes. And while I mentioned earlier, it may be default on day 1 when you provision your clusters, how do you have that assurance and automated assurance that your clusters downstream remain within the security compliance parameters that your assessor put out? Obviously, that's something that you don't want to have to run a scan every second Tuesday of the month during your lunch break just to ensure that the security integrity remains intact. That's why we've built Stigatron. So you can actually see Stigatron here on the right, and I'll be demoing it here in a minute. But Stigatron is that automated day 2 operator to ensure security drift doesn't happen. And if it does, it notifies your ops team immediately via webhook, email, or even Mattermost message. We want reactive GitOps to inform your downstream operators of these anomalies and give them the tools needed to bring them back into compliance. So here's what that looks like. So it's done in a myriad of different ways, but utilizing some under the hood scanning tools that we've built here at Rancher, we can actually go in and ensure things like the etcd directory is owned by the right user. You're not going in and chmodding 777, one of your directories within your Kubernetes structure. That's not something you should have to scan yourself. That's what we aim to do with Stigatron. Alleviate the need of operational security, or at least augment it. We don't want to be the end all be all, but we want to augment that journey and give you an automated path to discovering these anomalies. So let's do a quick little demo here. Let's see if I can switch over. Hopefully this worked. You should be seeing a login screen. This is actually a Rancher cluster that we have up and running for demo purposes. Let's see if I can remember my password here. And we're in. So this is Rancher CARBIDE. So if you've used Rancher before, things might look a little different. This is actually our CARBIDE distribution built with all the security standards, as well as a few other implementations I'll be talking about here. But you can see that difference here. So this is our multi-cluster management backplane. You can see here we're running clusters both locally on-prem within Harvester or hyperconverged infrastructure stack on Amazon EC2. And we're actually pulling all of those clusters into a single management backplane that you can authenticate with your IDAM or Active Directory user base and provide that single pane of glass for your entire Kubernetes enterprise. But let's go back to Stigatron. That's why we're here to demo. So here I'm going to an AWS cluster. This is a rather small cluster running in GovCloud. As you can see, it's 3 nodes. How do we ensure that this cluster is remaining secure? It may have been secure on day 1. What about day 365? That's where Stigatron comes in. So if we go over here into the left side pane of Rancher, we can click Stigatron and we're loaded to the scanning dashboard. So this is where we can actually create a new scan. So I'm just going to say create and say signal webinar, Stig profile. We have the opportunity to choose which profile we're actually scanning against. Soon you'll actually be able to upload your own profile so you can identify your POAMs for your organization. This is where that comes in. So we're actually selecting a 1.24 profile because I think that's what we're running on this cluster, and we can click create. So as you can see, it's actually utilizing our DISA-STIG and checking against that DISA-STIG right now, the integrity of that downstream cluster. So depending on the size of the cluster and the number of resources allocated to Stigatron, this will take anywhere between 2 and 25 seconds, right? So through the magic of television, I can go ahead and just open another scan here. And we're actually being transported into Stigatron itself. So this is actually Stigatron, and this is built in partnership with Heimdall from MITRE. MITRE put out this great tool that we've actually contributed to and support, and giving us that dashboard for all of our scanning needs. So as you can see here, we have the scan, its unique identifier, what version of the tooling, what platform, all the nice metadata we need. But you can see that we failed scans. We see some red here. We see severity, our compliance level. We intentionally deployed this on a non-stigged cluster to show exactly what your organization might see in a non-compliant status. So if you scroll down here to tree map, you actually see the 800-53 crosswalk that NIST puts out that many RMF packages require, dynamically generated specifically for your cluster. And you can see that crosswalk here. So commonly, assessors have to sit in Microsoft Excel for days on end, filling out each and every row of that 150-row table to match your organization and cluster to 853. We actually build that for you in this tree map, and this is completely exportable. I'll be showing that here in just a second. So if we scroll down as well, we can see the actual scans of each control. So we can see that this failed the actual controls that it references. And if I go to why it failed, we're actually presented, and let me zoom out here a little bit so we can see. We can actually see why it failed in the scan metadata needed to ensure or to actually perform that check. So here you can see that we did a PS FC on Kube API server, and here's the exact output from that independent node. So if you go down here, you can see all the parameters passed to it, as well as the second check here. So not only do we tell you when one of your STIG checks failed, we need to tell you more than that. Just telling you something's wrong isn't enough. So we actually give you the full-blown description of what that check entailed, how it impacts the severity, the NIST controls, but most importantly, we give you the remediation steps. It's not enough just tell you something's wrong. We want to get you to fixing it as well. So this is why we provide the actual remediation steps needed to bring that node back into compliance. So this is Stigatron. It's very powerful. One of the things customers commonly ask is, will Stigatron go in and fix my anomalies for me? The answer is no. And that's by design. We don't want to be in the business of modifying your production cluster. So commonly with RMF packages and assessments and ATOs, you have to have a defined state with your assessor of what that cluster is supposed to be like. We don't want to be in the business of dynamically changing that cluster and maybe covering up an anomaly that needs to be investigated. So we actually just notify your ops team via Mattermost, email, or webhook, and then leave it to your ops team to perform those remediations. As I mentioned, we'll actually give you those steps, but we don't want to invalidate your RMF process and or RMF package in the process. So we give that responsibility back to you. But when it comes to the RMF package, as well as actually interfacing with corporate tooling, we don't want to be the end all be all of all things security. We also have, NewVector, our security platform, which I would love to do another Signal webinar on. But when it comes to feeding the Stigatron data to the corporate repositories, we don't want to be a sink. We want to be a source of information. So if you click export here, you can actually see a myriad of different ways that you can export this data out of Stigatron. You can actually export it into an XCCDF file. Read that within your Stig viewer. We're not reinventing the wheel. We want you to use the tools and standards that DISA has already provided you. We give that to you in an XCCDF file, whether if it's XCCDF or checklist, bringing that back into the tools and standards your organization already has. We can export this data dynamically directly to Emaps, as well as other corporate tools, Tenable.io, ACAS. Stigatron is there to work with the tooling of the U.S. government, not compete against it. Additionally, I mentioned that 853 crosswalk here. We also have a spreadsheet opportunity. I pulled this up earlier just so I wouldn't have to switch different windows mid-flight. But as you can see here, we provide the scans in any format you want, CSV, Excel, and you have that metadata needed. You can pass this off directly to your assessor. So we want to make it easy to give you that radical transparency of exactly what's going on in your downstream clusters. So that's Stigatron. And going back to the deck now. So how is CARBIDE different from upstream Rancher? Well, like I mentioned, we built it on top of the private cloud with Azure Government and AWS GovCloud. We're built with SLSA Level 3 compliance. So one thing that we didn't talk about earlier is there's a great organization with SigStore that promotes SLSA. If you go to slsa.dev, you can find the standards and the ratings in which you can rate your organization or application against to verify your supply chain standards and integrity. We're proud to say that we've actually reached SLSA Level 3 compliance, which is very important to us to give you that peace of mind. So we do that, as I mentioned, through the vulnerability scans, attestations, and of course, Stigatron. So just having those digital signatures and those secure images aren't enough. As I mentioned earlier, we can give you the tools, but we want you to automate the process as well. So with great tooling such as Kubernetes by us, Enforced by Chainguard, OPA Gatekeeper, Kyverno, we actually give you policies that you can implement those policies within your downstream clusters and enforce that only Rancher government digitally signed images can run as your Rancher infrastructure on your downstream clusters. We want to give you the tools to automatically block those insecure images from even running in those environments in the first place. If you need something more reactive with not just deployments, but live day 18 type of validations, Chainguard has a great platform with Enforce that can do that as well. So we are not prescriptive here. We want you to have the tools needed and the tools approved by your organization in order to validate and enforce the security standards for your downstream infrastructure. So I mentioned earlier how we have a radical dedication to all things Airgap and Airgap customers. One other thing that we kind of baked into CARBIDE, which I thought, I wish I had this back when I was in a skiff. We've gotten a lot of great feedback on this. We've actually implemented all the Rancher documentation that we produce here at Rancher. We've actually integrated and embedded it within the Rancher product itself. So now when you deploy CARBIDE, you don't have to roll back over to your Nipper or low side box just to look up an API call. All of those docs are embedded within Rancher itself with zero hesitation, and you don't have to stand those up yourself. Additionally, we wanted to take it a step further. You can also see that we actually build and distribute the upstream Kubernetes documentation. So that's actually the full-blown Kubernetes website. You can go in and see examples, tutorials, as well as the API documentation, giving you that quicker frame of reference, even if you're in an air gap. So in summary, we've built CARBIDE to meet the needs and challenges of the U.S. military and federal organizations. We want to reach those federal standards quicker than ever and quicker than our competitors, to give our organizations and our customers the peace of mind that the software they're deploying is trusted, verifiable, and transparent. So as Dan mentioned earlier, the threats to supply chain security can be scary, but security should not be scary. Transparency should not be scary. We believe in putting that information out there for proper risk mitigation and acceptance by your assessor. So we do that with the enriched security supply chain, of course, our Airgap capabilities, and Stigatron as well. We are not done with CARBIDE. This is only the beginning. 9 months from now, 12 months from now, I like to think that the rest of the commercial world will catch up to some of the standards that Chainguard and ourselves are adhering ourselves to. We want to continue to invest in CARBIDE and build new security features and tooling for our customers. So soon we'll be able to announce something we're building here called Project Cowbell for all things edge. We will continue to expand the CARBIDE ecosystem and continue to invest in its capability to serve the mission. So how can you read more on this? What are some great resources? We certainly don't want this talk to be the end-all be-all of all things supply chain security. I check out CISA. CISA is doing a great job advocating for the standards and protocols needed to have proper software assurance when it comes to the supply chain. They have a great paper that I've linked here. Chris Hughes, who many of you have probably seen on LinkedIn, is a great resource, of course, with this podcast and blog on all things security and compliance. SigStore, of course, the Salsa website, as well as ranchergovernment.com and, of course, carbide.io. So with that, I want to hand it back over to, or actually introduce Adam Toy. Adam's going to come on and help us out with some Q&A.
Awesome. Thank you, Brandon. Yeah, we've had some great questions come in. I want to try to get to as many of those as possible, so let's just dive right in. So I think this first question is pertinent to both of you, just given the fact that both Rancher Government and Chainguard are sort of part of the open source community. But let's start with Dan. So Dan, because so much software that the government uses, proprietary or not, is based on open source technologies with shared libraries and dependencies, how can you ensure that virtually any software is safe?
Yeah, I like to think about that one in terms of, I guess, the second half of the question. We can't perfectly assure that any software is safe, whether it's open source or not. By all metrics, by all track records, open source performs a lot better in most security metrics and in most security scores than proprietary software. It's called Linus Torvalds' law, Linus's law. With enough eyeballs, all bugs are shallow. Open source software comes with a lot of transparency that enables us to find these security bugs. I realize sometimes the scanners might make it look the other way, where you scan something and open source software might look like it's full of vulnerabilities. That's not because it has more than proprietary software. That's just because we have a lot more metadata and visibility into it. So it's kind of this illusion of transparency. But yeah, against vulnerabilities, we can't ever be perfectly sure that software is secure. We can just do the best we can and apply hardening technologies as they come out.
Awesome. Brandon, do you have anything to add?
No, I think you hit it on the head. As I said earlier, there's no such thing as completely secure software, especially when you apply time to it. And when it comes to, closed source versus open source, even if you're using a closed source product, that is using open source standards behind the scenes, as well as internally developed libraries. So we believe in promoting that open source methodology, so you have that transparency to know exactly what's running and the dependencies that it has.
Awesome. Great answers. So this one's for Dan. Dan, since you yourself come from outside of the federal community, what have you seen on the commercial world? And what have you seen the commercial world really get right about security that those in the federal sector could learn from?
Sure. I think the biggest difference between the two that I've seen, and you do see this a little bit in the commercial sector in certain industries, like say maybe financial services, is the reliance on kind of that air gap as a security mechanism. An air gap can be a great security mechanism, but it changes the scope of your security programs and development programs a lot. If you're used to operating in something like the public cloud, then you're probably a lot closer to like a zero trust footprint, where you expect there to be network connections, you expect to have to mitigate a lot of vulnerabilities, and you have to have a lot of this continuous process in place. The trade-off is inside of an air-gapped environment, yeah, you can get away with not patching a lot of CVEs because there's no inbound network connectivity coming. You can be fine with software being a lot more out of date and a lot stale because the threat model is completely different. But at the same time, then you probably don't build up that muscle and that habit around continuous patching, continuous visibility. And it's going to be a big gap to switch from kind of that reliance on an air gap to operating in something closer to the public cloud. I don't think one is better than the other. I think they're just very different, and it's going to be a lot more work to move between them than a lot of folks realize at first.
That's great insight. Great insight, especially in the federal space, that it somewhat trails behind the commercial space to have that insight.
Well, it's interesting because I know I keep foot stomping and promoting CISA, but I just saw that CISA is hosting a SBOMorama in LA, and you think federal, why LA? They're doing public outreach to actually work with the commercial world, not just the federal companies and vendors and adopters, to set forth these standards. Security is good for everyone, no matter if you're running a home lab or a weapons system or your favorite off-the-shelf software. I think promoting these standards across the different markets are, it's paramount to ensuring that these standards are adopted and enforced throughout all organizations and assessment priorities.
Awesome. Brandon, this one's for you. I know you hit on this a little bit, maybe just to elaborate. How can an existing or potential customer get started with CARBIDE, and can CARBIDE images be utilized and verified within air-gapped environments?
Yeah, absolutely. So Airgap, as I said earlier, and Dan mentioned as well, Airgap can be a great methodology, both if you do so voluntarily or if you're forced to based on your mission set. We want to react and meet the need of our Airgap customers. So everything we do here at Rancher Government is built for the Airgap. So the answer is yes, you can verify those images even in an Airgap or DDIL environment. So I'm sorry, what was the first part of the question?
Or how can an existing or potential customer get started with CARBIDE?
Yeah, great question. So reach out to us at Rancher Government. You can go to ranchergovernment.com/CARBIDE. If you're an engineer and don't want to see marketing speak, you can go to ranchercarbide.dev, which is our public documentation for CARBIDE. Excuse me. We believe in being open and showing you exactly what the installation experience and what you can expect from CARBIDE. Those are our docs, and you can check it out at ranchercarbide.dev.
Awesome. I think we have time for one more. So the last question, and this is sort of for both of you. Beyond using the Chainguard and CARBIDE secured images, are there any other steps that we as engineers or administrators would need to take to ensure that our environments or applications are secured? Brandon, let's start with you.
Oh, wow. So that security and the standards set by your assessor differ from organization to organization. So it's very important for you to work with your cyber teams, your auditors, and your ISSOs to ensure that you're meeting the mark and those marks are properly identified. I believe in, using the right tool for the job, even if that means 4 different tools. So don't use security products necessarily as competing enablers, but use them in augmenting ways. Maybe you want to use Trivy for vulnerability scans. Okay, that's one part of security. You want to verify your digital signatures of an image. That's cosign. They don't knock each other out. They're not mutually exclusive. Use a collection of tools in order to attack your security baseline to ensure that you're meeting the standards set forth by your organization.
Awesome. Thanks, Brandon. Dan, you have anything to add on to that?
No, I think Brandon did it perfectly. There's a lot you have to do beyond just those things, but they give you a great starting point.
Perfect. All right. Well, unfortunately, I do think that's probably all we can fit in terms of time. So I do want to kick it over to Diego to close us out. Diego?
Thank you very much, gentlemen. Thank you very much, Brandon, Adam, Dan. Great having you. I remind everybody that you can view this webinar on demand and see previous Signal webinars on Signal's website at afcia.org/signal/webinar. There you will also find further resources on today's topics. If your questions weren't addressed during this event, we apologize and we will forward your query to our panelists. This concludes our Signal Media webinar. Again, a big thank you to our sponsor, Rancher Government Solutions, and to all of you for being with us. See you next time.